What would you like to learn today? Let's learn about shapes in a fun new way. Do you know what shape this is? Yes, this is a square. Let's make a square.
All right, so we had a little fun with the Play-Doh and the squares and such, but we're a little bit older, so we're going to get a little bit more beyond. Squares can be big and small in different colors. So today we're going to be talking about types of parallelograms. This is the last section of Unit 6, so this was a pretty short unit. And in 6.5, we're going to be defining rectangles, rhombi, and squares, and then we are going to apply attributes of rectangles, rhombi, and squares to solve problems. So a rectangle is a quadrilateral with 4 right angles. So there's 1, 2, 3, 4. It's also a parallelogram, but the distinct definition is that there are 4 right angles. Okay, so this is rectangle A, B, C, D. Now, conditions for a rectangle. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So you'll be writing in, then the parallelogram is a rectangle. So remember, when we know that something's a parallelogram, we know that the opposite sides are parallel. The opposite sides are congruent. The opposite angles are also congruent, and the consecutive angles are supplementary. Now, if we also know that one angle is a right angle, therefore we know that the opposite angles are congruent, and we know that the consecutive angles are supplementary. So that means all 4 angles would be right angles, and making it a rectangle. So who uses the definition of rectangle? Well, building contractors and carpenters can use conditions for rectangles to make sure the frame of a house has the correct shape. So if you have 4 pieces of wood per se, and you know 2 of them are the same length, and 2 of them are the same length, and you measure one of the lengths as 90 degrees, and you know that it creates a complete shape, you know that you have a rectangle. Here's an example of where this works. A manufacturer is building a mold for a desktop so that AB is congruent to CD, so the opposite sides are congruent, and BC is congruent to DA. So at least at this point, we know that that top is a parallelogram. We also know that the measure of angle ABC is 90 degrees. Why must ABCD be a rectangle? Well, we know that ABCD is a parallelogram because both pairs of opposite sides are congruent, and a parallelogram with one right angle is a rectangle. Therefore, ABCD must be a rectangle.
Do you know what shape this is? Yes, that's right. This is a rectangle. Let's make a rectangle. Rectangles can be small, they can be big. What do you know that's shaped like a rectangle? A bed? A door? A rug on the floor?
That rhymed. On to rhombi. A rhombus is a quadrilateral with 4 congruent sides. It's a quadrilateral with 4 congruent sides. So rhombus ABCD has 4 sides that are congruent to each other. And the conditions with rhombuses or rhombi, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So we know with parallelograms that opposite sides are congruent. Now, if we're also given that the consecutive sides or adjacent sides are congruent to each other, then therefore these two sides have to be congruent to each other. These two sides have to be congruent to each other. Therefore, all of the sides would be congruent to each other. So we're not going to spend too much time going over rhombuses. But now let's just quickly review the conditions of rectangles versus rhombus. So a rectangle is a quadrilateral with 4 right angles. So rectangle, the key thing is it's focusing on the angles. And it is a parallelogram with 1 right angle. If we know that it has 1 right angle, we then know that it has 4 right angles. A rhombus, on the other hand, focuses on the sides. So it's a quadrilateral with 4 congruent sides, and it's a parallelogram with 1 pair of congruent consecutive sides. So with rhombuses, we focus on the sides, and with the rectangles, we focus them on the angles. But also keep in mind that both of these are types of parallelograms. So they still hold all of the conditions of parallelograms. Like opposite angles are congruent, consecutive angles are supplementary, opposite sides are congruent. Yeah. So let's move on to squares. A square is a quadrilateral with 4 right angles and 4 congruent sides. A square is a quadrilateral, it's convex, it is a parallelogram, it is a rectangle, and it is a rhombus. So a square has the properties of all of them. And in particular, it has the properties of parallelogram, rectangle, and rhombus. Because it gets the rectangle from the 4 angles, and it gets the rhombus from the 4 sides. So this is square A, B, C, D. So if you could imagine if a rectangle and a rhombus got married and had a kid, it would be a square. Because basically a square is a mix of a rectangle and a rhombus. So the conditions for squares are quadrilaterals with 4 right angles and 4 congruent sides, and they are both a rectangle and a rhombus put together. Lastly, let's take a look at these properties and where they apply with different shapes, figures. So opposite sides are congruent. Well, that works for parallelograms. And opposite angles congruent, that also works for parallelograms. And consecutive angles are supplementary. That also works for parallelograms. So since all of these are parallelograms, we can mark an X for all of them. X, 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 X. So for all 4 of these, they have opposite sides that are congruent, opposite angles that are congruent, and consecutive angles that are supplementary. Now, all 4 sides are congruent. That would be a rhombus and a square. Now, a rectangle can have all 4 sides congruent, but not all rectangles have this. A parallelogram can have all 4 sides that are congruent, but not all parallelograms. All 4 angles are right angles, so this would be rectangle and square. And consecutive sides are congruent. This would be rhombus and square. All right. So with that, these were the 3 different types of parallelograms: are rectangle, rhombus, and square. We now have a general overview of the different types of quadrilaterals, from parallelograms, trapezoids, and kites, to isosceles trapezoids, to rectangles, rhombi, and squares. All right, good luck on your online quiz. Have a good one. That doesn't look like a square.
Squares can be all sizes. They can be big, they can be small. What do you know that's shaped like a square? A pillow.
No.
A window.
Kind of.
A piece of yellow cheese.
That is not a square. Those are not right angles.
A box filled with juice.
Certainly not a square.
Squares can be red, they can be yellow, they can be green, They can be blue.
Ooh.
They can be any color you can think of.